And welcome everybody to the Daily Space Weather Show. We'll be putting on a show this weekend. Some aurora likely coming to mid-latitudes. We're starting things out with some close-up imagery of the sunspot region that has been the culprit, or at least associated with the incoming space weather. It's an exciting time for space weather. We'll be having a lot of people tuning into the video, probably, assuming they can actually find the content. Don't mind us just providing the world's most comprehensive daily space weather and most detailed imagery of the sun. There is that northwestern limb where most of the action has been coming from, although there has been some activity also in the south central portion. We do have 3 new sunspot groups that two of them just rose and one of them just formed in the east. We'll get to that as well a little bit later in the video. There's the equatorial zoom. We have a coronal hole rotating it as well. So lots of stuff going on, including radio blackouts. Likely major aurora coming this weekend to the mid-latitude areas. Saturday night's going to be the ultimate one. And we're hoping for clear skies for another night in Lehigh Valley, Pennsylvania. Let's take a look at sunspots here. Here's the SDO continuum for December 14th and December 15th to date. And there is our colorized magnetogram. By tomorrow's daily space weather video, those sunspots in the northwest will be out of sight, but they'll still be capable of producing X-class flares, so don't be surprised to see more of that. We'll look at the magnetic fields later in the video in high res to give you an update on that. By the way, if you enjoy the content, make sure you press like. So thanks to our new YouTube subscribers. Congratulations on realizing the channel exists. And pardon my green aura. I guess I have some aurora borealis happening right now. Thanks to all of our YouTube subscribers. Thanks especially to the Smash team. If you want to support the channel, press the like button. If you're new, press the subscribe button. There is no other comparable daily space weather show. Get it onto your feed. Other ways to support the channel include becoming a member of the Smash team at smashomash.com/Smash team. There's our homepage, and welcome to the Neo Renaissance. There is the smashomash.com/Smash team page. That's where you log in, you click posts, you see your latest posts. And some exciting stuff going on. Exciting stuff when it comes to space weather. Today's featured product is forgive, remember, hold accountable. Because holding a grudge is like consuming poison and expecting the other entity to die. So forgive, remember, and hold accountable. Forgive and forget is so 2019, right? Right? Get it? Yeah, season's greetings, happy Christmas, whatever, happy whatever. And if that makes you offended, then happy press unsubscribe. And we thank you for that. Next is our featured product on the Amazon shop. It's amazon.com/shop/smashomash. It's vitamin D. People get a particularly low levels of vitamin D in the wintertime. So since we're in the darkest 2 weeks of the year for the Northern Hemisphere, get some vitamin D from our Amazon shop. That's one of the best sellers. A fantastic deal there. Save 20%, only $11.99 for a 1-year supply of Nature-Wise vitamin D3 500 IUs. You can also shop at our Hemp Lucid shop. Another way to support the channel there, hemplucid.com. Don't forget to enter the promo code SMASHOMASH10. Yes, SMASHOMASH10. It'll save you 10%. So again, hemplucid.com. On checkout, enter that promo code SMASHOMASH10 for your CBDs, your mushroom gummies, and more. SMASHOMASH10 will save you 10% at hemplucid.com. You can also find us, well, in lots of other places. But let's get to volcanoes, because it's about time. Here's the volcano rundown. The Reykjanes Peninsula continues to inflate. There still is a possibility of an eruption there. The magma has been moving, apparently, to the northeast. So, yeah, more quakes happening further north, and I should say farther north and farther east. So perhaps magma just moving places there, but again, the ground is still inflating. Krakatau's exploding, 4,000-foot ash plume over Krakatau. Semeru exploding, flight level 140, 14,000-foot ash plume over East Java. Merapi, 17,000-foot ash plume as it explodes. Santiaguido exploding, flight level 140. Nevado del Ruiz, new volcanic emissions over Colombia from it. No indication on the ash plume size. Please don't fly your hang glider or home kit ultralight aircraft over Nevado del Ruiz. Sangay exploding, flight level 220. It's a 22,000-foot ash plume. Revenador exploding. Do not pole vault the caldera. It's producing a 15,000-foot plume of volcanic ash, and if you could do a 15,000-foot pole vault, perhaps you should contact Guinness. Sabancaya exploding as well in Peru, flight level 300, an uptick there at Sabancaya. The Peruvian volcano, the largest ash plume producer in the world, flight level 300 over Sabancaya. 30,000-foot plume of volcanic ash. Next, let's get to seismic activity. There is the past 90 days, conveniently shown to you by volcanodiscovery.com. Here's the USGS site to go over quakes of a 5 or greater magnitude like this 5.1 of the band AC. Due north of Australia, it was at over 155 kilometers estimated depth and at only about 2 minutes after 0 hour this morning. 5.1 on the band AC. Besides that, very quiet for the past 24 hours. Some activity in Hawaii, but nothing big. Looks like only one quake of a 5 or greater magnitude for the entire 24-hour period. Except that 5.3, which happened kind of recently there. That 5.3 occurring near the Isle of St. Helena in the South Atlantic Ocean, a very desolate portion of the world there. Not a lot of traffic down there in the South Atlantic. Continuing on to some more space stuff. First, some more solar stuff. Now, we did have multiple additional CMEs, and I suspect there is another one headed this way. It came from this region right here, and we've got some spectacular imagery to show you today. Difference imagery, which is not normally what we show. Today we've got some, because it really helps to create some contrast for Earth-directed coronal mass ejections. So there's our house favorite wavelength, 171 angstroms. Here's a little teaser for the difference imagery. That's 193 plus 304, and the 304 is in running difference mode, I believe it is. Running difference mode there for 304, 193 in the regular original imagery, not difference. So anyway, next, getting to some more stats here. The current 10.7 centimeter radial flux is now at 144 solar flux units for the 10.7, otherwise known as the F107 to some. There is the past year of the radial flux depicted by that black line. The red line is the sunspot number. Moving right along to the Space Weather Enthusiast dashboard, and NOAA's now expecting a greater geomagnetic storm tomorrow night than tonight, so fingers crossed for that. We've got clear skies in Pennsylvania, so it might be a great time to see the aurora. We'll show you how momentarily. First, we've got some more imagery and the Ask a Particle Physicist segment coming up. So here's the Enlil spiral. That's NOAA's forecast. And basically expecting, looks like a combined CME there. And what's up with that? Is that what they forecasted? I don't know. That forecast definitely different than yesterday, but hey, there it is. There's the forecast. Expecting a greater geomagnetic storm tomorrow. I would tend to agree. Don't be surprised to see a KP8+. NASA's forecast is non-existent, but pay attention to those dotted lines because we're going to be talking about those in just a minute. Let's get to our Ask a Particle Physicist segment. And by the way, that is one of the many ways you can contribute to the channel. If you'd like to ask a particle physicist segment, well, we've got one in mind. So anyway, here comes the segment. We'll tell you about how to ask the question after we review the following.
Okay, so the question is, The endless spiral shows a curved line between every object and the sun, referred to as the IMF line. I assume it has something to do with magnetic connection. Could you please elucidate on the nature of that connection? Gladly, I'll gladly do that, Atmanhotep. So, what we're talking about here is this thing. By the way, there was an X-flare just a couple of hours ago. But then we'll tell you about it, no doubt. So, okay, here you can't actually see any lines, so we have to go someplace else like this ISWA. Here on heliosphere you can see the endless spiral, in case you want to reproduce what I'm about to show you. So, yeah. So these lines that you can see here are exactly that. It's the connection of Earth, in this case, this yellow thing, to the surface of the sun. And what kind of connection is this? Well, it's a magnetic connection, just as you've said. So it's quite literally the magnetic field lines exiting the sun and getting to Earth. So it's the interplanetary magnetic field, right? It's the solar wind magnetic field, you might call it as well. And well, if you remember one of the previous episodes where I talked about like how particle interacts with magnetosphere of Earth, this doesn't really reach Earth. That's kind of what I'm about to say. Like it reaches vicinity of Earth, right? But we have our own magnetosphere, which kind of interrupts this flow, if you wish. So it's not like like the ground is connected to the sun or something. No. Like you have to include all the dynamics of plasma in our magnetosphere into consideration as well, obviously. But if you are somewhere near Earth, it would connect to you, yes. Or, for that matter, if you're anywhere else, you would connect to some point on the solar surface. In fact, there is... Sorry about this. There is... this service also has a map which shows where exactly we're connected to. And it's here, you can see Earth, which is incredibly weird, to be honest. I don't know why it's here. In fact, I doubt it is here, because this is from SDO, basically from geostationary orbit. So this is how we see the sun. I have no idea why the connection point is here. It should be usually somewhere around here. It's like to the right from the center, because again, the solar wind is curved, right, into this Parker spiral, because the sun rotates, spins, I mean, around its axis, and that it curves the solar wind and the magnetic field lines associated with the solar wind. So you would expect, you can see that this line emanates from somewhere to the right, like this is a top-down view. So if we're looking at the sun, it should be slightly to the right, so you would expect it to be somewhere here. I don't know why it is here, maybe it's some sort of glitch. No idea, honestly, but yeah. So what kind of connection is this? Again, I'll remind you that you can see the polarity. IMF is interplanetary magnetic field, basically the magnetic field of the solar wind. So what is negative polarity? It means that the line, magnetic field line, enters the sun. So it's this blue area which projects into infinity sort of here. Not to infinity really, but around, what is it, 2 AU, right? 2 astronomical units is what we're seeing here. It's actually curved significantly, like somewhere around between Jupiter and Saturn. Actually, this curvature becomes so high that it wraps a whole 360 degrees, okay? So at infinity it would be very complex. But anyway, so yeah, this is what's happening. The blue lines means the blue thing, the negative polarity, south polarity, means that the lines enter the sun, and the red one, the north, means that the lines exit the sun. Okay, so this is what's happening. And what kind of connection is this? What does it mean that we're connected to this area on the sun or that area on the sun? Well, it means that particles, charged particles, they move. How do they move? They spiral around magnetic field lines, right? Just like indicated here. So imagine this magnetic field line connecting us to the sun. It would mean that all the particles that are situated here can travel along this line, spiraling around it. Okay, that's why when let's say there is a solar flare in a region which we are connected to or somewhere nearby, we can see a proton event, like something here, spikes, because the fast particles which are produced by the flare just jump on this highway, so to speak, on this line of connectivity, and they arrive at Earth really quickly. Like these fast particles, they are fast, so they have a velocity of a significant fraction of the speed of light, could be like 30 to 40%, maybe even higher. So they arrive in like maybe 20 minutes, whereas the regular plasma, the CME, takes like a couple of days to reach us. So it's a big difference, right? So to answer your question shortly, it's just a line of the magnetic field, okay? And yes, it connects us to the sun in the sense that we may receive, let's put it this way, it's much easier for us to receive any sort of charged particles from the region connected to us than any other region, really. Because again, the conductivity of solar wind is orders of magnitude higher along the lines of force, along the magnetic field lines, rather than in perpendicular direction. There's basically no current in perpendicular direction. And speaking of current, by the way, in the area where we have a transition from north to south magnetic field, we have the current sheet, right? This is the white one, the white thingy. That's where the current flows. Why is the current? You can see it's like a cross section from the vertical cross section, sort of. We're seeing the Earth kind of from the side here, so you can see it's very, very twisted, the current sheet. So here's the region of south polarity, where the lines enter the sun, and here's the north polarity, where the lines exit the sun. So we're currently connected to the north. So the lines of force go to us from the sun, whereas here they go into the sun from us, okay? So why do we have a current between those two different regions? Well, it's because, again, if you have different magnetization here and here, there should be a current according to Maxwell's equations. There should be a current that causes this change. And that's how the current sheet appears. And generally speaking, in plasma, if you have two regions of different magnetization, you will always have a current sheet between them. And some examples we've already examined, what was it, 2 weeks ago, when I talked about how particles move in the magnetic field of Earth. Okay, hopefully this answers your question. Yeah.
So that was just awesome. And talk about perfect timing, because we now have a solar proton event. So that's actually what Eugene was talking about there, with the protons spiraling along the field line. Just perfect timing for that. The proton event started to occur only a few hours after he sent me that video, because he shot it yesterday. So perfect timing there. And the likelihood of even higher levels of proton events continues, because we do have a very high likelihood of solar flares still moving forward, so still a very high likelihood of seeing an X-class flare on that northwestern limb. If you want to contribute to the Ask a Particle Physicist section, head to smashomash.com. You can link to the forum there, smashomash.com/forum. It's completely free. Lots of different forums there about different sciences and things. Make sure you go subscribe to Eugene's channel. He's got lots of different eclectic videos about all kinds of different things, many of which have nothing to do with science. So perhaps check those out. Thanks to Eugene. Again, make sure you go subscribe to Eugene the Philosopher, the greatest living philosopher since the unfortunate passing of Robert de Nameland. Again, make sure you press subscribe to his channel. The eons are closing. Let's take a look at Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from space. It's our geospace magnetosphere movie. Now, once again, tonight's geomagnetic storm is looking pretty weak so far. We don't have the most favorable magnetic field orientation, and like us, NOAA is now expecting better space weather tomorrow night. But there is some space weather. So here's our ground magnetic perturbations map. This is one of the ways you can check and see if the aurora may be visible in your location. We've got a high likelihood of substorms here at the moment. So that's the past 4 hours of Earth's magnetic moment from the ground. We showed you it from space. Here it is from the ground level. And KP index is currently just under unsettled here at 3.33. KP 3.33. Yes. 3.33. Somebody will be freaked out about that. Oh, no, it's half of 6.66, folks. Oh, my God, I'm so spooked of the KP index. Oh, no, space is so scary. Part of my sarcasm. So here are some ways to see if you might be able to see the aurora. One is on the Space Weather Modeling Framework. Not the Space Weather Modeling Framework, the Space Weather Prediction Center, the SWPSI, as Tamitha Skov calls it. You can look at the Aurora 30-minute forecast. That's one of the ways to have some idea if the aurora may be visible in your location, although I've got some other ideas for you as well. So here's one that I like a little bit better if I'm in North America, which I am. Oh, there's also an auroral forecast. It'll just draw a line for the whole night there. So that's another experimental data set there, the aurora view line for tonight and tomorrow night. So that's pretty cool. Unfortunately, only in the northern hemisphere. But this one I really like also because this actually shows you induction into the power grid. This is a thing that occurs simultaneously with space weather. So when you see this really lighting up, that may be a time that the sky may be lighting up at the same time. So try that. The geoelectric field map for the U.S. and Canada could be very useful for your aurora filming endeavors. And if you think you see the aurora, make sure you break out your camera. Remember, folks, most of the aurora is in ultraviolet light and not visible to the naked eye, but your camera sees it. So looking at Reykjavik here, and no aurora currently visible over Reykjavik. And of course, there is a lot of city light pollution, but the aurora over Reykjavik gets quite bright. Next, looking at the real-time solar wind, and the current situation is, well, here it is from ACE. And that's actually a little bit outdated, so let's just skip that and move to the Discover. Discover currently showing a little under 20 protons per cubic centimeter for the solar wind density, much higher than yesterday. Solar wind velocity also quite a bit higher. That is CME 1 of 2. So that is over 503 kilometers per second. The highest we saw there was about 40 protons per cubic centimeter. We got up to about 38 there or something like that, 37 approximately. So that is the scenario, and up here this top pane is what I'm talking about, the magnetic field orientation not being optimal for big time space weather. It's not going to induce a lot of current there at a field strength of 10 nanotesla for the BT and the BZ of -4. GOES magnetometers here are showing some big perturbations in the past couple of days. Let's show a 7-day chart to show the smooth stretches and then the geomagnetic unrest stretches. So here you can see the typical GOES magnetometer type curve. And then you can see some space weather happening in some of these areas here. Some big gyrations happening there in the magnetic fields detected in the outer portion of the outer portion of the outer Van Allen belts is where the GOES 16 and the GOES 18 do their orbits. Next, our top view ecliptic plane field plot. And part of the reason why what Eugene was talking about suddenly switched is because we got to a South Pole current sheet. I suspect that's what's going on because that was gong data. So if you look at this, we've got this small little South Pole oriented sector where, like he said, the field lines are going into the sun. And then over here you've got this sector where the field lines are coming out of the sun. And that could be why he was seeing such an odd location there for the connectivity point. But We may have to start showing that image that he showed there. We'll do that perhaps on tomorrow's Daily Space Weather video. But there's the animation of the top view ecliptic plane field plot. And Earth may snap into a North Pole current sheet at any moment here. So you can see a very small South Pole oriented magnetic sector there. North Pole sector very close. Could be only hours away. It could happen basically instantly. It could have already happened, as this data is over an hour and a half old when we created the video. Next, our line of sight ecliptic plane field plot. I say it all the time, the magnetic environment can change suddenly, and it has been in the east. So you can see a bunch of waving around going on over there. That is magnetic indecision. So this is the kind of scenario that could be fertile ground for sunspots to rapidly form, which is exactly what we've been seeing happening. Again, 3 new sunspot groups have shown up in the eastern hemisphere. Here's our line of sight field plot. And you'll see drastic motions happening over there in the east, which would be the left side of your imagery. The solar B field there changing around quite a bit in the past 4 days, the time period depicted. We always show 4 days on the Daily Space Weather videos of these systems. So here's our line of sight coronal hole plot. And we've got indecision happening right there in plain view. Coronal holes that are changing polarity. So this could be quite a volatile environment here. We could see additional new sunspots rapidly forming there, especially east of center disk. Let's get the coronal holes from SDO. So there you go. There's the past 24 hours. Again, I think there's another earthly directed CME from this. You'll see a CME happen right in there. Probably another Earth directed CME. We'll get to it. Here's a little closer view of the main coronal hole. Some weird limb darkening happening there. Anyway, we'll get to it. We don't want the video to be too lengthy, though, so let's move on to sunspots. So sunspots are the next subject here we'll cover, and there you go. There are sunspots still just hovering around the average. There are around 120 sunspots here, a little bit below it now. Looks like 119, something like that. Here's our flare probability monitor and scoreboard, and once again, we still do have an increased likelihood of large solar flares, especially in that northwestern limb. That's going to continue for at least 36 hours, maybe even as long as 2 days. So still a high likelihood of major flares in that northwestern limb. And we have a proton event going on too, so let's blast through some more stuff. Here are your SDO magnetic fields, the photosphere magnetogram, and let's just skip to the continuum. So mostly stable here for the past 24 hours, although a new sunspot group did indeed form over here right in there. Not sure if that's beta or alpha class. I suspect it's probably beta gamma class. And 2 more sunspots rose up here in the northeast as well. So at least 3 new likely named sunspot groups in the coming 24 hours. And let's get the solar energetic particles because we've got some. So look at the proton flux is still rising here. So still haven't peaked out on the proton flux. We're having a solar energetic particle event while CMEs impact. So all of this is, once again, it's got to do with exactly what Eugene was talking about, the way that there's a preference for the particles to circle the magnetic field lines, which is exactly what we're seeing happening. We talk about it all the time, how it's more likely for an SEP event to happen during a coronal hole high-speed stream or a CME impact, and there you have a perfect example of it. Just getting into warning levels here, and by the way, we are having polar radial blackouts already, so especially southern hemisphere polar flights, which are very rare, there'd be a significantly greater radiation exposure. And you can see some areas there in the north also where polar flights would see some higher exposure to radiation. So it's like something like 10 times as much as normal or something like that. It can even be as high as 100 times normal. But, you know, for people that aren't flight crews, it's usually not that big of a deal. It's like getting, 10 CAT scans instead of 1 CAT scan or something like that. So, yeah, some significant solar energetic particle events going on there, and the levels are still rising here. So we have very high likelihood of large solar flares, we have equatorial blackouts, and we have ongoing polar radio blackouts. Now, these can last for days, and in this case, don't be surprised to see them last for days. I would expect this to last maybe 2 or 3 days. So, and we still don't know where the peak is, because like we just showed you on the last frame, the SEP has not peaked out. So, lots of exciting stuff happening with space weather. I suppose today we'll have to make quite a few shorts. Next, the X-ray flux. And there are the past 3 days. We've only had one M-class intensification in the past 24 hours. It was pretty big, an M7 approximately. And let's take a look at flares from SDO. Here's one of the optimal wavelengths, 131 angstroms. Gotta love it. And don't worry, if you'd like a closer view, we've got that covered. And don't worry, we've got an even closer view as well. There's the extreme close-up for all of you extremophiles. And we've also got 94 angstroms. So this is like 131. This is the extreme ultraviolet emissions from highly ionized iron. Some very hot iron plasma there in the sun's atmosphere, known as the corona. Pretty freaking sweet times for space weather. And before we get to the latest CMEs, let's take a look at something a little bit more chill. A star chart. So that's what's going on overhead, Lehigh Valley, Pennsylvania. Let's press now. There we go. And perfect timing. So we've got Orion here rising over the east-southeastern horizon. A very distinctive constellation, largely because of these 3 belt stars. And if you weren't aware, we're going to show you how to find Betelgeuse. So if you're able to identify the constellation Orion, Betelgeuse should be super easy to find. Here's how. These 3 belt stars right here, 1, 2, 3, have a middle star which points right at Betelgeuse. So check it out. This is actually depicting the obscurement of Betelgeuse. That was in the news. There's an occultation happening there as a 60-kilometer main asteroid belt asteroid moves in between Earth and Betelgeuse. So again, this central star of the belt creates a perpendicular line that points right toward the largest single object visible to the naked eye, the red supergiant star Betelgeuse. Just rising up over the horizon here as we approach the winter solstice. So here's your solar system forecast coming next. This is what's going on today. That's where things will be in a week on the 22nd. And we're almost a week from Christmas, folks. Have you finished your shopping? Visit our links if you haven't. The occultation of Betelgeuse is the apod.nasa.gov picture of the day, the astronomy picture of the day. That's what's going on. Next, CMEs. And, yeah. So we got some more, and dag, we got some freaking sweet imagery here. Here are yesterday's CME images. See yesterday's daily space weather video for a greater analysis of those. Here come today's. That's 67 frames from yesterday. Here are an additional 76 from today. And I got good news and better news. We got another CME likely to hit harder, and another one likely on the way. So this isn't helping me that much, so let's move on to our next frame. We'll show the C3 here as well as the C2. Yeah, there's another one headed this way, folks. That one's going to arrive sometime, let's see, probably early on the day on the 18th. Early on the 18th. So another CME headed this way. Here's a little closer view. It occurred later in the day today. And that might even be another one there. So there might actually be two that are earthly directed. I suspect there are two earthly directed CMEs from today. So there are enough here that it's actually getting a little confusing for me. We've also got another sun diving comet. So if you look right in here, there's a comet right there, another one making its way in. See that comet right there? And it should be a long time in the C3. There, you can see it right in here. Another comet showing up there. We'll also show stereo A, which I haven't even looked at myself yet. Here comes the stereo A imagery. Difference imagery on the right, raw coronagraph on the left. There's a good one from yesterday. And here comes some from today. So there's one at about 10 o'clock this morning we saw it. And then another one here at maybe, oh, I'm not sure on that. That looks like inconclusive. I still say one of those is earthly directed. That's got some outdated imagery. Let's take a look at our custom coronagraphs. Now, just so you know, folks, today we put difference imagery there in the middle. That's actually 193 angstroms. That's 193 difference imagery in the middle. And then, just multiple CMEs happening there. Pretty tough, frankly, to see what's going on, to get a bead on anything. One event does look like it was on the far side. It looks like there was a massive flare on the far side because you can see the entire outer corona just lighting up there. That does not look like it is associated with an Earth side event, so I suspect there's something going on the far side, like a massive flare. And yeah, besides that, geez, that is tough to tell, but I think there is at least one more CME on the way, expected to arrive early in the day on the 18th. That's my best guess. If I had to bet, that's what I'd be betting on. It's just that I ain't got to bet. You be the judge. Let us know what you think in the comments. If you've got a bead on any of those possible CMEs. This last one right from here, I believe, has earthly directed components. So that's my best guess. There's just that's 304 plus 193 angstroms with the running difference. Or that's a base difference. No, that's the running difference. So it's a 60-minute running difference. It's the frames from 60 minutes ago with the current frames subtracted from them. That's why it's called difference imagery. You have a comparison of the older pixels versus the newer pixels. So yeah, Pretty exciting times for space weather, I would say. And let's continue on, as we don't want the video to be too lengthy here. So let's get to the rest of our regularly scheduled space weather, bonus features, and meteorology. We want to show you if it's a clear night tonight, and it looks like it is for Pennsylvania. So sadly, the geomagnetic storm likelihood is actually dropping here. So tomorrow night we do suspect will be better, though. Saturday, December 16th. So anyway, there are solar filaments from Cerro Tololo, Chile. We'll also show filaments in grayscale because there are some huge prominences on that eastern limb. Oh, and by the way, check it out. There was indeed a CME right here. You'll see this filament. It's there, and then it's gone. Wait for it. There it goes. Only part of that is likely to have splashed back down. The rest of it is partially headed toward Earth. And more activity happening down there as well. Check it out. It looks like another CME there. Another radio burst likely happening here as we create the video. Also, massive prominences here around the northeastern limb. A high likelihood of large solar flares in the northwestern limb. It's good times for space weather. Good times. And here come bonus features. Yes, bonus features, I tell you. First, charging hazards. And we have some significant satellite charging here of the surface charging variety. Not likely to damage the satellites, but it could cause some communications breakdowns over places like the Middle East, East Africa, and the northwestern Indian Ocean. Next, the GOES electron flux. There you have it. Past 3 days. A little bit higher than we may have expected here. This first CME impact not super strong. So what can I say? There's the past year of the electron flux. There it is over the past, I guess that's 1 month. The last roughly 30 days there, and NOAA is expecting a downtick, and frankly, so am I. Next, the layer where it's measured, which is the F layer of the ionosphere. Yes, the F layer. How do I do that? Oh, there we go. There is the ionosphere and its vibrational glory. And we are seeing quite a few low-frequency anomalies there. No real surprise to our regular viewers. Here's the anomaly in megahertz from a 30-day median. You'll see lots of red on there. But probably not as much as we'll see tomorrow night. Hoping for clear skies for all of you aurora chasers. Here are the latest images. That is 2330 Universal Time Ionogram, 2330 Universal Time Anomalygram. We'll also show the WAM, the whole atmosphere model. That's your global ionosphere nowcast. We'll also show the total electron content. And don't forget the latest imagery of the closest star. So before these sunspots are gone, let's take one final look at them. And there you go. There is the sunspot associated with all of that activity. And that sunspot looks like it is a little bit less magnetically complex. However, once again, folks, proximity to the limb itself is a risk factor for large flares. If you consider it risky, I don't know, maybe you consider it risky, who knows? This sunspot here is not too shabby either. It is beta gamma class. Maybe beta gamma delta, let's see. It is beta gamma delta class, barely. A couple deltas in there where we have magnetic shear. Couple little areas right here in the middle where there is some delta-ish looking activity. So, again, that one is looking like it's becoming increasingly unstable here as time goes on. There's the full disk rock back. And before we get to meteorology, nullschool.net is down, folks. Nullschool.net not working. So we've got the Tokyo wind map. So that's not what we normally show, but if you look at the Earth wind map, oh, it's back. Nice. So that's pretty sweet. And today we'll look at space briefly. There's what's going on with the auroral oval. Those are the likely places to see the aurora. Let's break out the regularly scheduled meteorology segment. There are the surface winds of the east. There are the jet streams. Oh, those aren't the jet streams. There are the jet streams. Those aren't the jet streams either. What happened? Son of a. There we are. There are the jet streams of the east. Here are the jet streams of the central world. Surface winds of the central world. Surface winds of the west. And the jet streams of the Americas. Next, clouds and fog over the Americas. You can use a shortwave radiation map to see if you'll be likely to have clear skies. Shortwave radiation depicts clouds and fog even at nighttime. Who needs a visible satellite? By the way, we got this powerful low here making its way across Kansas as we make the video. There's a great view of that low. Probably not taking Toto to Oz. But a great example there of a counterclockwise rotating northern hemisphere low pressure system. This is rain accumulation for the next 3 days, and the East Coast is going to get inundated quite a bit here. Florida, also the Carolinas, expecting some heavy rains there. That's the Euro forecast. Here's the GFS model, expecting South Carolina to get the brunt of it there. Again, GFS model for the next 3 days of rain accumulation. There's Euro model, GFS, Euro model, a GFS, rain accumulation. Next, weather.gov. Some flooding coming to the East Coast, places like New Jersey, also southern Florida, coastal portions of the U.S. Here come some weather forecasts from Tropical Tidbits. Yeah, tropicaltidbits.com. Go say hi to Levi Cohen on Twitter, perhaps. Here is the 72-hour GFS pressure and precipitation forecast. Next is your total accumulated precipitation forecast in inches. Same model, the GFS 72-hour. Next, we've got the culprit, the force that drives your weather from west to east, the jet stream forecast for the next 72 hours. Also the GFS model. So quite significant temperature variations here as this Canadian air makes its way across the U.S. It's a bunch of hot Canadian air. So anyway, that's a temperature anomaly forecast in degrees Celsius for the next 72 hours. Also the same model, GFS. Next, lightning. What do we got? None over North America at all. Here's a real-time lightning map depicting all of the world's lightning, at least the portions of the planet where there are sensors. And if you want to look more into that, head to lightningmaps.org and click around. You'll find things that I don't care to explain in this video. We'll close out with Doppler radar, clouds and fog, and water vapor. So there's the full 50-state view. Here's the lower 48 view as that low makes its way toward Iowa. There is clouds and fog. Clear skies over Pennsylvania. Fingers crossed for better magnetic field conditions to see the aurora. There are the water vapor data. Here's a recap. Vertical motion in the air column. Clouds and fog. And water vapor. And here's me tuning out because I've got to get this video up on your screens. Thanks for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Whoa.